I've been working on OpenMuscle for a long time. It's an open source prosthetic sensor that also can be used as a human interface device. This is the latest version, relatively slim, and it's meant at predicting finger movement by just being worn on the forearm. Today, we're going to actually show you what it looks like to actually put it in VR and for training. And the final at the end, I'm going to show finger prediction for both hands while I'm wearing it. We got the package from JLC PCB. This is the first time I had the assembly service purchased on top of these two boards being made. We have a rigid board and a flex board for the FlexGrid version 4. On the bottom left is the version 3. It's horizontal, as you can see. Overall, version 4 has a lot of upgrades that we're going to benefit from. We still have to populate some of the rest of the components, and that should be easy. We got the ESP32, the multiplexer, the ZIF connector, and finally the buttons on the top right. Now that we have the rigid PCB set up, we're going to create a stack for the housing. We're going to actually use the shelf liner as the bottom layer. We're using this template to actually cut everything out. And the top two layers are going to be cloth. This cloth is going to house both of the flex and rigid PCBs. And I'm using my limited sewing skills to get us at least a working prototype. Now that it's done being sewn, we're going to cut out the outside of it, make sure all the PCBs fit inside, and go ahead and now solder the battery terminals onto the board, and that would be the final step before the full assembly and one of the first tests. Make sure that you don't let those LiPo terminals touch each other because that could be a fire hazard. The final step is just getting the flex PCB plugged into the rigid, and it's just the final connector. And the connection works quite well. My phone is a nice debugging tool to see the heat map of the sensor. And once everything is verified, we can go on to the next step, which is actually wearing the devices. So I'm now wearing two of the OpenMuscle FlexGrid bracelets. These are the version 4. We have a VR application, and we'll make sure it's powered on. It's able to detect both fingers using the built-in hand gesture recognition from the Quest 3S. Oh, we even have the rotation of the hand. So the model is from the past recording. And we can see the hands are glitching a little bit, and it looks like it predicts these fingers. There's only a train off of one session, so we're gonna record. So we're predicting and recording at the same time. We can see that we have the two different hands there. It sees easily the hand opening and closing. The more we record, the better it gets. There's some dangers, of course, of overfitting. The reason why pass-through is so nice is that we could actually capture ourselves doing something, for example, picking something up, performing an action. So I think this would be great for humanoid robotics data set training. Because this would give us more data for when our hands are out of the field of view. Now we do actually have another label mechanism. This is the LASK 5. It is good without VR, but we're limited in the motion that it's capturing, but it directly correlates to the fingers. So we can really hone in the model's ability to detect the strength of finger curls. That's why it's called the LASK system, and it stands for label seeking. Probably look ridiculous, but this is actually easy to wear, and I can do some chores. Now it's a little bit tall, so it's a little bit restrictive if I'm trying to do something, but the idea is this to be very passive, that you could wear all day, or specifically doing chores. You could record this for training humanoid robots. As a prosthetic sensor, hopefully it would fit into the socket of the prosthesis, so that way it would just capture those muscle contractions and hopefully move the robotic hand. And that's the main impetus for this project. So thank you for watching this video. Please hit like or subscribe if you like this content. That goes a long way. You can support me through Patreon if you wish. There's also a Discord server. Just say hi, things like that. Anything in the comments helps me out, helps bring this project visibility online. There is no marketing budget at all, so a little goes a long way. And as always, let's see if we can make a positive difference in this world. Till next time. Sorry for the extreme close-up. Okay. Okay, it should be recording on both devices. Yeah. So sorry for the flickering sign. This thing is actually pretty useful. I don't know if you use an IV holder as a soldering station, the TS100 or 101. Pretty nice. But I use it also to focus if I'm using a manual lens. Put it right at my head height, and then I can go to the camera, focus it, and then come back. Again, this is ideally